Hi everybody, this video is going to start us off on Unit 5. Unit 5 is going to cover linear equations. I want to tell you about a couple things. We have decided to put these 2 days together. 5.1 and 5.2 are going to go together, and 5.3 and 5.4 are going to go together. And I'm okay with that for a lot of reasons, but one reason is that these were designed to be done on last year's schedule, which is a 50-minute period, and now we have 90-minute periods. So I really think it's going to be doable. We can do this. We can do 1 and 2 on the same day, and then 3 and 4 on these 2 days, this same day. And then our quiz over this is going to be on Friday, November 20th. So today's lesson is covering 5.1 and 5.2. It's all about slope formula. And so let's talk about slope formula. Let's do a little bit of review. How do we know if something is a function? We know if it's a function 2 ways. Every x has only one y, or it passes the vertical line test. And depending on what kind of information we have, we might use either one of these definitions. Okay, that's if a graph is a function. What about if a graph is linear? If a graph is linear, it has a constant rate of change. What that means is it goes up or down by the same amount, the same y amount, every time, every x time. And so throughout the course of this video, we're going to talk about all 4 of these concepts. Okay, in this next section, we are looking at some examples. We're deciding whether or not it's a function, and then we're deciding whether or not it's linear. So this question, is it a function, yes or no? Remember, for the function, we look at the vertical line test. And if we take that vertical line and go across, then we think about, is it ever going to hit it more than once? Doesn't hit it more than once, and so yes, this is a function. Now when we say linear, what we really mean is a straight line. A straight line. Is this a straight line? No, it's not. Another thing is, how do we tell if it's linear? If it goes up or down by the same amount every time. So like here we can tell it's going up really quickly, but here it's not going up so fast, and then it goes up quickly again. And so that is not linear because it's not going up by the same amount every time. Okay, let's look at this next one. Think about our vertical line test. Yes, it is passing the vertical line test, so it is a function. And then is it linear? Well, yes, it's a straight line. That root word, line, means that's what we're looking for. It's going up or down by the same amount every time. It doesn't actually go up or down at all. And so it's still a line though. Okay, next example. Is it a function? No, it's not. How do I know? Because it's not passing the vertical line test. Is it linear? No, it's not. It doesn't make a straight line, so it can't be linear because it doesn't make a straight line. It's not going up or down by the same amount every time. This last one is kind of tricky. Okay, vertical line test. Does it pass the vertical line test? No, it doesn't, actually. Because the vertical line test is like if it hits it more than once, and when we did it over here, it was hitting it here and here. But when we do it on this one, it's hitting it everywhere. It is not a function. Is it linear? Yes, it does make a straight line. It's going up or down by the same amount every time? That's a tough one, but I'm going to stick with yes on that. These kind of lines, these vertical lines, are definitely unusual because they are not functions, but yet they are lines. Okay, how do we find the slope of a line from a graph? So your paper is kind of gray right here, and it was too dark to write in, so I'm writing this information over here. There are 3 ways to find the slope of a line, and we will talk about all 3 of them today. We can talk about rise over run. We just count. How much does it rise? How much does it run? We can talk about this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's a very common formula that we use. Or we can look at it this way. I'm not sure if you've ever seen this before. That triangle is a delta, and delta means change. So this means the change in y over the change in x. How much is y changing divided by how much is x changing? Now, because we are doing this all in one day, I might skip some of these examples. I don't think we have to do every single one. Mainly, I think you've done a lot of these before in middle school. Okay. So if we think about rise over run, that's the easiest way to think about it. How much does it rise? How much does it run? Usually we go from left to right. And so on this one, the rise, well, it's not actually rising, it's falling, right? So that's going to be a negative number. And so we count, it's going down 1, 2, 3, and it's running, going to the right, 1, 2, 3, 4, 5. So the slope on this is negative 3/5. M is the letter that we use to stand for slope. Let's look at the next one, rise over run. How much is it rising? How much is it running to get from one point to the other? And so the rise looks like it's going up 1, and the run is 1, 2, 3, 4, 5, 6, 7. I believe that's 1/7. Okay, remember I said we don't have to do every single one, so I'm going to skip this one for now. I'm going to go on to number 4, because number 4 is kind of tricky. If we think about rise over run, well, it doesn't have a rise. The rise is actually 0, and the run is 1, 2, 3, 4. And that's a fraction that we can reduce, and it does reduce down to 0. And let's skip over to number 6, and let's think about the rise over run for number 6. The rise is 1, 2, 3, 4, 5, 6. The run is 0. Okay, I don't know if you remember this, but anything divided by 0 is undefined. And we think about slope. Slope is like the steepness, and so it's how steep is it? Well, this one has no slope. It's 0 steepness. It's not steep at all. This one, though, is so steep that it's undefined. So that's kind of where that ties in. Let's turn the page. All right, once again, remember I said we don't have to do every single one, so we're not going to, but we will start. Anytime you have a whole number, let's put it over 1. So 2 over 1, a slope of 2 means you go up 2, this is the rise, and this is the run. So we're going to go up 2, and then over 1, and up 2 over 1, up 2 over 1, etc. And it's good if we can connect those with a straight edge. And so if you have a straight, it could be a ruler, it could be the edge of a note card, it could be the edge of a book. If you have something you can use for a straight edge, that's going to make your lines look much, much better. Okay, let's go to the next one. Again, we said if it's a whole number, it's not a fraction yet. If you want to put it over 1, you can. And so this is a rise of 0 and a run of 1. Rise of 0, run of 1, etc., etc., etc. So our line is a straight line horizontal. And so again, we want to use a straight edge and connect our points. Okay, let's take a look at this one. The negative, it can go either way. The negative can go on the top or it can go on the bottom, but it cannot go on both. And so if it goes down 3, 1, 2, 3, and then right 5, we're going to be off the paper. So let's go the other way. Let's go up 3 and left 5. And we can do it again if we need another point to give us another something for our straight edge. So we're going to go up 3 and left 5. Okay, so again, I'm going to use my straight edge. I'm going to connect those in a line. Undefined. So I don't know if you remember we talked about it. An undefined line is straight up and down, vertical like this. Okay, I said I wasn't going to do all of them, so let me skip 2 of them. I'm going to go to this next example, this example B. So again, a negative could be on the numerator or the denominator, but not both. In other words, we could go down 1 and right 2, down 1, right 2, or we could go up 1, left 2, up 1, left 2, and then we're going to connect those with a straight edge. So that's a slope of negative 1/2. I actually want to do this one just because it's a very common problem. So again, if it's a whole number, we put it over 1. So it means we go up 1, right 1, up 1, right 1, up 1, right 1. If you want to go the opposite way, you can. It would have to be down 1, left 1, down 1, left 1, down 1, left 1, because again, when you, a negative or negative is positive. So we can go that way as well. And again, this one appears a lot because it's a 45-degree angle. It goes up 1 over 1, up 1 over 1. And so I want to make sure we get to that. Okay, last section on this page is going to talk about rate of change. And a rate of change describes how one quantity changes in relation to another quantity. And so let's just take a look at the problems. When we look at these, we're going to look at rise over run. One thing that is, I think, an important word when you're thinking about slope is the word per. And slope is rate of change. And rate of change, that word per means like miles per hour or beats per minute. That is slope. And so we know that slope is rise over run. So if we look at this in context, so we're going to look at what is on the axes. So these axes are labeled. And so our rise is going to be the altitude. It's measured in feet. And the run is the time, and it's measured in seconds. And so we could call that feet per second. And that's what this is asking, is how many feet per second is it changing? And so if we look, we do have some numbers here. They give us some points that we can use. So it's going, and now you have to pay attention to the units. It's not going down 2, it's going down 1,000, because this is 1,000. So it's going down 1,000. And I'm going to put my units on there, that's feet. And the run, so that's the rise or fall. And then the run is from 60 to 80. It's not 1, 2, 3, 4. It's from 60 to 80. How far is it from 60 to 80? Excuse me, 60 to 180. Well, I don't know if you can tell, but these are counting by 30s. So you could count 30, 60, 90, 120. Or you could just do the subtraction, and we've talked about that briefly, that y sub 2 minus y sub 1. So you could take 180 minus 60, and that is 120. Now, I do want to put this in my calculator. And when we do slope, a lot of times we want it as a fraction because that's a rise over run. But when we do word problems like this, I think it's better to have it as a decimal. And so if I put that into my calculator, 1,000 divided by 120, negative 1,000 divided by 120. It says negative 8.3, and I need my units. That's feet per second. In other words, let's take a look at what's going on. This is an airplane landing. It's going down 8 feet every second. That's what that means. It's going down 8.3 feet every second. Let's look at the next one. Distance traveled, time. So our rise is the distance, or the miles. The run is the time, or the hours. So this is miles per hour. Miles per hour. So how many miles per hour is it going? Your copy might be difficult to see. But on my copy, I can see a little bit better. And I can see that there's a point there, a point there, a point there. Like actually all of them have an intersection point. But again, it's not up 1 over 1, up 1 over 1. It's up 50 over 1 and up another 50 and over 1. Or if you want to look at the whole thing, you could say it's up 250 and a run of 5. But that reduces to the 50 over 1 that I was just talking about a second ago. So this is 50 miles per hour. All right, I'm going to end this video here, and there's going to be another video for the next 5.2.